Yo fam, what's up? In this video, we'll be talking about how you can create a crazy animation like this. I think in YouTube, no one has ever done this type of animation. The car is fucking racing, the Ferrari, and there is like grid, it is continuously rendering, and the wheel is also spinning. So the crazy part of this animation is not that the car is moving. The crazy part about this animation is that you can fucking customize this color. So if I change the color, as you can see that in real time the color is changing. So you can customize your car like this. So if I click on the glass tab and if I do this, you can see that you can also customize the glass as you like. So this looks so fucking cool, and today in this video we'll be building this. So how you can create this with using Three.js, Next.Js, and we'll build it in TypeScript. So let's get right into the video. So as you have already seen the crazy animation of this, so now what we will do is we will start coding this project from scratch. So I have already set up this project. I have already started a development server for this project, and this is the code from our previous video. So what I will do is I will just minimize this, and inside the source and app folder I will create a different route called car. So inside this car I will create another folder called component, and to create a car route you have to do is you have to create a file called page.tsx, and I will create a component rafce, so that it will create a react arrow functional component, and I will make this at car page, and I will default export this car page. So what I will do is I will create a different component for this car animation, so that it will be easier to render this car animation inside this car page. So I will create another file called car animation.tsx, and I will create a functional component like this, and I will give it a height of screen and bj of Fuchsia 500, so that we will make sure that this route is working or not. So inside this page I will render it like this, car animation, and if I save this and if I just reload the page, so as you can see that our page has been working perfectly. So far so good. So let's start building our animation. So I will go inside this component and I will hide this. So firstly what you have to do is you have to mark this component as a client component, because there will be animation and interaction. Use client, and firstly what I will do is I will create a use effect, because all of our logic will be inside this use effect, and I will create an empty dependency array. So to render our 3D scene, I will use this div as a canvas. So I will use this div as a canvas to render our 3D car. So what I will do is I will create a ref to target this div. I will create a ref called main container ref equals to use ref, and I will pass it a type of HTML div element, and the initial value will be null. So I will copy this and I will pass it as a ref here, main container ref. So to use this main container ref, what you have to do is you have to create a variable main container equals to main container ref dot current, so that you can access this div right here. So now we will have to create a variable for our camera, scene and controls. So what do I mean by that? So in a 3D in a 3D world, there is a camera to view the scene, and there is scene. Scene is like anything that you can see. It is generally referred to as scene, and the grid is like the animation that you have seen. The flooring that you have seen, it is like grid like structure. So we will also create a grid, and there will be controls and wheels. So let me first initialize a variable called camera. To set up our camera, it will be a type of 3. Okay, firstly I'll check my package file. There is not Three.js install. So what you can do is, firstly you have to install Three.js. So I forgot to install Three.js. So what I will do is, I'm using pnpm as a package manager. So if you are using npm or any other package manager, you can install Three.js. So I'm using pnpm, so I will write pnpm add 3. So this will install Three.js for me. As you can see that the 3 package has been installed. So now what I will do is, so for the camera I will have to assign its type. So it will be a 3. Firstly I have to import the Three.js library before we can use it. So what I will do is, I will import it as import star as 3 3 from 3. So what this does is, so the Three.js library is imported as 3 from the Three.js library. So it is complaining us that the Three.js has not its type. So what you can do is, you have to also install the type. So if you're not using TypeScript, then you do not have to use this, or you do not have to assign any types. So I'm using TypeScript here. So what I will do is, I will install the Three.js type. So to install Three.js type, it is really simple. It's the package called type slash 3. So I'll have to install it as a dev dependency. So I'll do pnpm add dash d. I think it's dash save save dash dev, and you can at the rate type slash 3. Look it here, at the rate type slash 3 dash save dash 3. Okay, so I will install this type of Three.js. As you can see that our types has been installed on Three.js. So let me define the types for this camera. So the camera will be of type of 3 dot perspective camera, and we have to also define the scene will be of type 3 dot scene, and we have to also define the grade. For the grade, we will use the 3 dot grid helper, and for the controls, we will use the orbit controls. So this will the orbit controls will help us to move the 3D model in any direction we want. And we'll also have to define the wheels, because we will animate the wheel to rotate, so that our car feels like it is running on a highway, it is running above the grid. So now I will do is, I will do 3 dot object 3D. It will be a type of object 3D. So don't feel pressure if you do not know about this type. You can just look at the Three.js documentation, or you can do a simple chat GPT, and you can find out their type. So I will define it as empty array first, and after that I will create a variable to determine the window height and the window width, so that this variable can be reused in our function. So I will create a variable called win height equals to window dot inner height, and for the width I will create win width equals to window dot inner width. So okay, it is looking pretty much nice. And for the renderer also, we have to create a ref to render our 3D model. We will use a ref for this. You can also store it in a variable, but it is a good practice if you are using Next.js or React to use a ref for that, so that it does not trigger any re-render on your project. So I will create another ref called I will create a renderer ref, renderer, yeah, renderer, render, yeah, renderer ref equals to use ref, and it will be of type of. So I have moved the renderer above, and I'm using a variable called renderer to store our renderer ref, so that we can reuse it into our logic. So after setting up our renderer, I will create a function. This will be our main function. This will be our main logic function to render our, to initialize our 3D model, to initialize our 3D renderer, so that we can set up our camera scene and position, so the main and grid. So I will create a function called initialization to initialize our 3D render. So this will be the main heart of this project. So watch very carefully. I will create a function called initialization, initi ali jet atn. Initialization equals to, I'll create an arrow function like this, and firstly we have to render our container, to render our 3D scene. So for this we will use a renderer. So what I will do is I will write renderer code here, and I will explain you line by line after I finish writing the code. So firstly I will have to do renderer equals to new 3 dot, sorry, don't stress out if you do not understand this. I am just writing the code first, and I'll explain it to you later line by line. So firstly I have to assign the 3 dot webgl renderer, and I will put it anti alias to be true, just like this. And after that I will use renderer dot set pixel ratio function, and what I will do is I will do window dot device pixel ratio, just like this. And after that I will use renderer dot set size, and for this I will use win width and the win height, which we have defined here. So the win width is this, and win height like this. And after that I will use renderer dot set animation loop to continuously render our animation, just like this. So the animate is cannot, it is telling us that it cannot find name animate because we haven't created this animate function. So what I will do is I will comment out this code just like this, and I will write other code. Renderer dot tone mapping equals to 3 dot ACES filmic tone map. And after that I will use renderer dot tone mapping exposure to 0.85. 85, I think it is 85, just like this. So let me explain what this code does. So this code snippet, this code I write here, it is used to render 3D graphics with smoother edge. So the what does this first line does? Renderer equals to new 3.webgl renderer and anti-alias true. So what it does, it initialize a renderer that uses WebGL to render the 3D graphics. WebGL is basically a low-level language that is used to render the 3D graphics, so that the graphic system inside your computer understand this code, and it tells that when and where to render the pixels, the 3D pixels onto your screen. And this anti-alias true, it enables anti-aliasing, which smooths the edge of the rendered object. It's like some it basically it is used to smooth the 3D quality. It is used to enhance the quality of your 3D model. And for the set pixel ratio, it is uh, it sounds like it exactly sounds like as it is written. It adjusts the renderer to match the device pixel density, like improving the visual quality. So the quality of your 3D material will render as per your device performance. So on lower end devices, it tries to reduce the quality of your 3D model, and on the higher end devices, it will improve the visual quality to for the pixel ratio. And it is for the size for our renderer to use our window width and the window height. And for the tone mapping, so what this tone mapping and tone mapping exposure does, it like it is like a specific tone mapping is like a specific function or a specific algorithm to adjust like the color and brightness, making the rendering look more cinematic and realistic. And the tone mapping exposure, it controls the like the brightness. So the 0.85, it is the perfect value that I have found, and you can play with this value to adjust the brightness of the model that you are rendering on the canvas. So this is the thing that this renderer function does. So we have set up our renderer. I will write comment as setting of the renderer, just like this. And if I put this, okay, nice. So this code set up the renderer for us. I hope you can understand this. And after this, what we will do is we will have to open this renderer to our main container, so that this renderer is. So now what I will do is I'll have to open this renderer to our main container, so that it will create a canvas to render our 3D element. So how you can do that is you can use like this main container ref, not main container ref, main content, sorry, main container dot open child and renderer dot DOM element. So what this code does, it will open this renderer to our main container, so that the main container will created as a canvas, and it will use to render our 3D scene. Now that we have set up our renderer, what I will do is our next step is to set up our camera. So I will like this, setting of the camera. So for the camera, I will write camera equals, I will assign value to this camera variable. So for the camera, you can use like new 3 dot perspective camera, which comes from Three.js. And for this variable, you have four different inputs: FOV, aspect, near, and far. So the FOV is like the field of view of the scene, and the near is how close, and near and far is like how near and far are you are from the scene. So there will be value for this. So you will have to provide this four argument to this function. So I have tried and tested the different values, and so I will assign the good value to this function. So for the first one, FOB will be 40, and for the aspect ratio of the ratio we'll have to provide is the window width and divided by window height. So you'll have to provide the width by height ratio, like this: win width divided by win height. And the third one will be the camera frustum near plane default 0.1. It is like the near value. So how near should you be, the camera would be from the scene. I will provide a value of 0.1, and the far will be 100. So you can play around with these values, and I will set the camera position like this: camera dot position dot set not equals to, you'll have to give a value. I will give 4.25. X, Y, and Z, you have to set up the camera position on X, Y, and Z axis. So for the X axis, I'll give him 4.25. For the y-axis I will give it 1.4, and for the z I will give it minus 4.5. 4.5, just like this. So let me explain what I did here. So the three dot perspective camera creates a camera with the perspective projection, which mimics human vision by making distant object appear smaller. So 40 is this is the field of view. uh, it is like in degrees, which controls like how wide the camera view angle is. A smaller FOV zooms in, with a larger FOV zooms out. And for this aspect ratio, we are giving win width by win height. It is typically set to the width and height of the rendering area to avoid the distortion, so that the scene will be perfectly fit into our uh, display. This is the near 0.1 is the near clipping plane, which means the objects closer, meaning objects closer than this distance from the camera are not rendered. And 100 means the far clipping plane. That means that the object farther from this distance are not rendered on the scene. So this is the this camera. So this is what this function does. And for the camera position, we have set up 4.25. This is the x, y, and z value of the camera. So this is how you can set up a camera. So we have set up our renderer and we have set up our camera. And the third one to set up is our. So now after setting up the camera, we will set up our controls. Setting up the controls. So now let's set up our controls. So for the controls, we have to create controls using our orbit controls. So I will create controls like this. uh, I will create controls equals to new orbit controls. We are using orbit controls for controlling our 3D scene. So what does this control does? It is used to like rotate and zoom in, zoom out of our 3D scene. As you have seen in the beginning of the video, I was able to rotate the car using my mouse. So it is only possible using this control function. It is using possible this orbit controls. So you have to use like this, and you have to pass it in the orbit controls. You have to pass like camera and the renderer dot dom element, just like this. So orbit controls, it is like a utility in Three.js that enables like rotation and zoom feature and panning around a target point. And the camera, you already know what the camera is. And renderer dom element, it is the canvas where the control should listen for our event. So it is the area where our 3D scene is rendered and our event will be listened. And after that I will use controls dot max distance equals to 9. So what it does it. So max distance, it is used to limit the camera where the user can zoom out for that from the target. So in this case the maximum distance is 9, which keeps the camera relatively close to the scene. So after that you can also give the max polar angle. Controls dot max polar angle equals to 3 dot math utils dot degree to radian. In Three.js, you have to use radians as a degree. So I am using 90 degree. So this function convert this degree value to a radian, which is used in our max polar angle. So max polar angle, it restricts the vertical orbit range, controlling how far up or down the camera can really move. In the y-axis, in how far up and down the camera can really move. So it converts the 90 degree into radian, limiting the camera's angle to looking straight up or down. And it also, this setting also prevents the camera from moving below the scene, manipulating a more intuitive and the natural range, so that the scene and the model does not disappear from the camera. And we are also using this setting the orbit target position. Controls dot target dot set, and you have to pass the x, y, and z value, 0 and 0.5 for the y, and in z axis I'm also using 0. So this is the try and tested values, so that it perfectly fits in our scene. So a control target, it is the point in the 3D space the camera orbits around. Like here it is set to 0, 0.5, and 0, which is slightly above the ground level, 0.5 units up along the y-axis. And after using our control setting, the final step is to update our controls. So for updating our controls, you can use controls.update function, and you can call this. So it recalculates the control setting, ensuring that any changes like the position, maximum distance, polar angles take effect immediately. So this configuration allows user to interact with the 3D scene smoothly while keeping the camera within the specific bounds. So this is what the control does, and we have already set up our renderer, camera, and the controls. After that, after setting up the control, we now have to set up our scene setup. So scene basically it's set up for the background lighting environment and the fog we'll be creating in this scene. So firstly we will create scene just like our renderer and the camera and controls. You are noticing some patterns, like for the first time when you are initializing like renderer, camera, and controls, you are using new and 3 dot. If it is renderer, you are using WebGL renderer. If it is camera, you are using 3 perspective camera, and if it is controls, you are using orbit controls. So for the scene, you have to use scene equals to new. You are using 3.js, so for the 3 it comes from 3.js, 3 dot scene. You can call this like this. So it is like the container for all objects like light, camera, which is used in the 3D space. And for the scene we will use our background color. What will be the background color for the scene? We can use it like this: scene.background equals to new 3.color, and for the color you can pass it like this: 0x and 3 3 3 6 times 3 3 3 3. So we are setting up the scene background here. So it is set to dark gray. This color palette is dark gray color, which is neutral background and allows our 3D objects to stand out. And for the environment, we can use scene.environment equals to new RGBE loader. You have to import this RGBE loader, and for loading I am using a car/packle. You have to use as HDR, which is a environment for our 3D scene, which is used for the light and reflection effect on our 3D model. So you can download it from internet also. So I will give you all the asset link on the description. So what I will do is I will create inside this public folder I will create new folder called car, and inside this car folder I will be providing you all of the asset that is required for this project. So I will just copy and paste this HDR file here. So I will use /public /car/packle sunset 1k.hdr. So this will be provided in the description, so you do not have to worry about anything. So it is like environment and environment for our scene, which our 3D object will react to our, how the 3D object will react to our light and the reflection for the more realistic environment. And after this we have set up our environment. We have to map its type. So what you can do is you can do scene scene dot environment dot mapping. Mapping equals to 3. It comes from 3.js library, equirectangular reflection mapping. So there is like reflection and refraction mapping. These two are different terms. So you can use this equirectangular reflection mapping just like this. So it specifies that the environment map should wrap around the scene in a equirectangular projection. This mapping is ideal for like HDR images as it allows objects in the scene to reflect the environment realistically. So you so it I know it sounds complex, but what it basically does is we are creating more realistic scene for our car so that it feels natural and more realistic. So you do not have to worry about anything. It is like making our reflection more good in our 3D model. So and the final step is to add our fog. So we can also add fog into our scene like scene dot fog equals to new, which comes from Three.js new dot fog, and we can use our gray color 1 2 3 4 5 6. So this is our gray color, and near and far value 10 and 15. So what this line does is it creates a fog effect which gradually fade objects as they move farther away from the camera, adding the more depth and the atmosphere. So what this scene really does is it creates a realistic scene with the atmospheric fog and environmental reflection and neutral background, enhancing our 3D experience in our browser. So we have set up our renderer, camera, controls and scene. Our next step is to set up our grid. So it is the floor, the material which our car will run. It is like a path. So let's set up our grid. So it is our ground plane on which our car moves. So I will write grid setup just like this, and I will create it like this. So for the grid also we are using grid equals to new 3 dot grid helper, and we are using this value 20 40, and the color white color fff 0x fff. So what does this grid helper does? So it creates a grid plane with customizable dimension and color. So it is the line will be white color, the line of the grid will be of white color. So the this constructor takes four arguments like 20. It is the size of the grid. It will be a 20 by 20 area, and 40 is the number of segments which will divide a grid into 40 cells across each axis and creating a more realistic and finer grid. And this is the color of the primary lines, and this is the color of our secondary lines, which is both white in this case. And let's add some opacity into our grid so that it looks more realistic. So grid equals to grid dot material. So we are modifying the material opacity in this case. We are using this 0.2 value, 0.2. So grid material dot opacity, it controls like the transparency level of the grid, which is set to 0.2, which is like 20% opacity, making it mostly transparent. And the subtle this effect, this subtle grid does not distract from other objects in the scene, but it still provides a visual guide which will look nice after we have rendered our 3D object. And we'll have to disable the depth writing for this grid. So I will use grid dot material dot depth right equals to false. So depth right, what does it means? What does depth right means? So depth right determines whether the grid should write to the depth buffer. Setting it to false means that the grid won't obscure objects behind it. It allows other 3D elements to be visible through the grid, so that it does not block our 3D scene and helps us to run more smoothly. And we'll also add the grid material dot transparent to true, so that it will be more transparent. For the opacity shading to work effectively, this setting allows the grid to render with transparency. And after setting up our setting, we have to add this grid to our scene. So just like above other, we have to add this to our scene dot add, and we have to add this grid to our scene. Just like this, we can add this into our scene. So this setup provides a light semi-transparent grid that serves as a reference without like blocking the view, making it ideal for precise positioning in the 3D scene. So up until now we have set up our renderer, camera, control scene and the grid. So we have finished set up our grid. Now let's set up our material. So before setting up material, let's understand what material is and what it is generally used for. So material is basically designed for realistic rendering, and it has some advanced properties like the metalness, roughness and the clear coating properties, which are generally used for mimicking or the copying the carpent or other reflective surfaces. Like now let's set up our material. I will material setup, material setup, and you will understand when I write the code. So let's set up the body material. Body material equals to new 3 dot mesh physical material, mesh physical material, and inside this you can specify the clear coat. Sorry, firstly you have to specify the color. Color will be new. I mean, you can specify the color like this, hashtag ff triple zero. So our body of the car will be of this color. This is the red color, I think. ff 123440, and we have to specify the metalness. For the metalness I'll give it 1.0, and for the roughness I will also give it 1.0. So these properties generally makes our car like more natural and more realistic, and we'll have to give the clear coat property 1.0, and for the clear coat roughness 0.03. So these values are the tried and tested values which works perfectly for me. And if you do not, if you are not satisfied with this values, you can modify this value and see what you can really do with this value. Okay, so the color defines, let's talk about its properties. So the color defines the base color of the material, and the metalness defines the how metallic the material appears. So our car is built of metal, so we are using this metalness property, and it ranges from 0 to 1, and 0 means non-metallic and 1 means fully metallic. And for the roughness controls the surface smoothness and how blurry or sharp reflections appear. Or roughness of 1.0 means the material is highly rough. I mean, in realistic car you can see that the car is generally the surfaces are not too much of a perfect smooth, they are generally rough. So we are giving one value. And for the clear coat, it adds a transparent glossy layer on top of the material. A value of 1 means the clear coat layer is fully enables the clear coat layer fully, simulating the effect of clear varnish or coating like carpent. And for the roughness, it is like the roughness of the clear coat layer itself. So uh, why I am giving 0.03? Because it is a very low value which makes the surface more smooth and shiny, resulting in the sharp reflections. Now we have set up our body material. Now let's set up our details material. So what is detail material? So the detail material is like it is used for design elements like accents, trim or other metallic details that are present on the model. So now let's set up our detail material. So for the detail material, the process is also similar. I will create a variable called const details material, equals to new 3 dot mesh standard material. So we are using mesh standard material, and for this we will give the color. I will give the color of white, FFF, and for the metalness I will give it of 1.0 of fully metallic, and for the roughness I will give it 50% roughness, 0.5. And let's see our glass material. Const glass material equals to new 3 dot mesh physical material. We are using physical material in the glass material, and for the color I will also give it of white. For the metalness I will give it of like 20%, 25%, and for the roughness I will give it of 0, and for the transmission will be 1.0. So let's talk about this standard material. So standard materials is like supports the realistic lighting and reflection, but the lacks the advanced clear coat properties of mesh physical material. It is like often used for metallic or non-metallic surfaces with varying roughness. So it is basically used for our realistic lighting. And for the glass material it is like designed for the transparent parts like glass. So glass material can be used for our window or the front window of the glass of our Ferrari, which we will change later. So it also simulates the look of clear and the reflective surfaces. And physical properties like it supports the transmission, and it is suitable for the transparent or translucent materials like glass. So transmission one means it makes our glass look fully transparent, allowing every light to pass through, like it emulates the real glass. So now we have set up our body material, details material, and glass material. I know it is little bit of hectic to do all this kind of code, but 3GS is a little bit tough. You have to be patient in order to learn this, because this type of knowledge is not shared by anyone. So I am here to tell you that you should rewatch this video 2 to 3 times in case you do not understand. So now add shadow. We'll also add shadow texture. For the shadow, I will use const shadow equals to new 3 dot texture loader. So the shadow also gives the realistic feeling of the car. Load, and for the shadow we'll have to use image for the car shadow. So all of the resources will be provided on description. So I will just copy and paste the asset here. I'll paste it right here. So this is the shadow that we are using for our car. And to load our shadow we can use like slash public and slash car slash Ferrari ao.png. So I will remove this public file, and if I save this, okay, the shadow has been loaded. And now we will use gltf loader to load our 3D model, and we will use with Draco compression, so that the 3D model will be run smoothly on any device. On any device, I mean the device that are compatible with 3GS. Now we have set up our materials and shadow. Let's set up our the Draco loader. So what do you mean by Draco loader? So Draco loader is basically a compression library to improve the loading efficiency, and it reduces the file size. I mean the 3D files are pretty much heavy, and most browser cannot handle that. And if your PC is running on low end requirements, then uh, it will face difficulty in rendering your 3D models, and the website will become too much slow. So the Draco loader will help to significantly reduce the file size, and it compress the geometry data, and it is really useful for complex model where the reducing load time is pretty much important. So now let's set up our this decompression Draco loader. So for this I will set up it right here. uh, Draco compression. with gltf file, gltf loader. We are also using gltf loader to load our 3D models. So for initialization we will using drag loader, drsu drag loader equals to new dracoloader, which comes from Three.js. And we have to specify its path. So we are using dracoloader dot set decoder path, and you have to have this decoder path library to use this Draco loader. So all the asset will be in the in the description, and I will push this project on the GitHub, so you do not have to worry about any asset. So I will just copy and paste this file, gltf loader file, gltf Draco loader file. Just give me 1 second. Inside car I will give it a loader and compressor, compressor compressor. Inside the compressor folder I will just copy and paste this file. So the path will be slash public slash car slash compressor slash gltf. So inside this file there is uh, a javascript code that is used to compress the 3D model. So after you have specified the path, let's use the loader. Const loader equals to new gltf loader, gltf loader, just like this, and use loader dot set drag loader, which will be drag loader. We'll be using this drag loader. So what this code does, it is using this public file loader, and we are setting drag loader as this as this loader which is present in our public file. So after the compressor has been applied, let's use our 3D model. I will use a load 3D model. Now we will load our 3D model. So for 3D model to load, we are using loader dot load, and for the 3D model also I'll have to copy and paste this file. Where is this file? Loader dot load slash public slash car slash ferrari.glb. So our 3D model will be in glb format, and we are using this function gltf, and let's do the car model equals to gltf dot scene dot children 0. And if you console log this loader, let's see what it does. Console dot log car model, and if we save this, and if we go here and look on our console, sorry, we haven't called this function yet. So to call this function we have to use initialization, initialization. We have to call this function right here, and if we reload this page, we are using a public route here. So I'll remove this public, and if I save this, I'll also remove this public file, and you have to use it for the gltf. You have to use it like this. If I now save this, so our model has been successfully fetched by the gltf loader, and as you can see, uh, this has been console log. And inside this children, as you can see that there are many objects, and if you open any of these objects, you can see that there are main wheel, rear right wheel, rear left wheel, front left wheel, front right, and steering wheel. So these are the properties that you can change in the car. So if you go here, and there are lots of properties here, lots of object inside object, and many things that you can see, like wheel, tire, center brake, knots. So everything the car is made of, the object is present here, and you can also modify this object based on the input that you can provide. So this is really a 3D model looks like after fetching it by the gltf loader. So now let's let's find the body of this material. So I will use const body equals to car model dot get object by name. We are using this function which will find body object inside this whole object, inside this children. It will find the body object which is present, I think, which is present right here. You can see that there is a body object, and this body object, if you change its color, the car color will change. So we are modifying this uh, object. So firstly we are finding this body object as 3 dot mesh, as 3 dot mesh, because we are using TypeScript, so we have to define its type. So its type will be 3 dot mesh. And if body is present, assign the body dot material to our body material which we have defined right here, like this. Body material just like this. Okay, so we are using our own custom body material from here, and we are replacing the car already specified car material with our body material, just like this. And for our also details and class material, we have to do the same thing. I will just copy and paste this object array. And for so we will be also modifying the rim front left, rim front right, rim rear right, and rim rear left, and trim properties of the car. So I'll have to map this array, and for each part I will do an arrow function just like this. And for the rim part I will find, firstly I'll find this part car model dot get object by name, and I will run this function in this every array. So I will find the rim front left, rim front right from the part as 3 dot mesh, because it will be a type of 3 dot mesh. So if this function find this rim part, what we will do is we will assign our rim material. We will assign our this detail material to our 3D model. So this is what this will helps to customize our rim material and the body material colors. So I will give it like rim part dot material equals to details material which we have defined above. So we have used body material, details material, and we have to use our glass material. So for the glass material, it is also the same step. We have to find the glass in this object material, and assign it with our this glass material which we have custom made. So let's do that. So for the glass I will use const glass equals to car model dot get object by name glass as 3 dot mesh. And if glass is found, glass dot material equals to glass material. Okay, nice. So now for the wheels, we will using wheels dot push. We have to use this for the wheels also. For the wheels I will push car model dot get object by name wheel underscore front left, and I'll just copy and paste this, and I'll tell you what it really means. 1 2 wheel front right, rear right, and rear left. Front right, rear left, and rear right. So basically what this code does is, like, this code fetches the wheels, and we are fetching the wheel by using the get object. We are finding this wheel from our car model, from our 3D model, Ferrari.glb, and we are pushing them into an array called wheels. So this is simple. This is simple. We are using wheels variable here, and we are pushing all of the car wheels onto this variable. It is just as simple as that. So that this array could be used for animation or transformation. So why we are storing these wheels on this variable? So that we can animate this wheel uh, and rotate it so that our car looks like it is moving. So that is the whole purpose of this code. So now our final step is to add mesh and add some rotation to the mesh. So now let's get right into this coding, and our initialization function will be complete. Now let's create a mesh first. I will write it creating a mesh, creating the mesh. Now I will give it a comment like this. So for creating a mesh, it is simple. You have to assign a variable called mesh and use the new 3 dot mesh, just like this. And you can use the 3 plane geometry just like this. New 3 dot plane geometry, and this geometry has some value. You have to give the width segment, height segment. So I am using this value 0.655 into 4 comma 1.3 into 4. And for we are using new 3 dot mesh basic material, and we have to use it for the shadow, map shadow. So we have created this shadow file here, shadow variable, which we are using this image. So we have to map this shadow image into our model. So we are mapping this shadow, and for the blending, blend sorry blend blending, you have to use 3 dot multiply blending. And for the tone mapped, for this tone mapped will be false and transparent should be true. So what this geometry does, it is so this 3D object, it is made of a geometry shape, and here it is used to create a flat plane which is like a shadow. And for this plane geometry, it depends of planes with a width of 2.62, which is this value, and height. So this is width and this is height. So it is a shadow plane, right scale, which is scale relative to the car. So and after that we are defining the material here. So for the material, we are using this map shadow, which sets the texture for this plane, and which is coming from our image, this shadow image. And we are using blending, which is used to darken the plane based on the shadow texture color, and this makes the shadow appear naturally, just like a natural process. So it disables the tone mapping and enable transparency, means only the shadows areas are visible, making the background of the shadow texture invisible. So this is what we are doing by creating a mesh. And now we have created the mesh, we have to position its shadow. So to position its shadow, you have to use mesh dot rotation dot x equals to, we are using pi value, max dot pi divided by 2. So it rotates the shadow plane 90 degree, because mat.pi will be 180 degrees, 180 degree by 2, which will be 90 degrees, and aligning it horizontally to lie on the flat ground beneath the car surface. And we have to specify its render order, which will be mesh dot render order equals to 2. So it ensures the shadow plane renders after the car model. So after the car has been rendered, the shadow will be rendered, preventing depth conflicts and ensuring the shadow always appears below the car. So this is what this code does. And now the final step will be to add this car model to the mesh and adding the car model to the scene. So now let's do that. We are using car model dot add. We are using this mesh. We are adding this mesh on the car model and we have to add onto the scene. Yes, on scene dot add car model. Okay, so it looks pretty good and let's see what it does. And if we refresh the page, so nothing is rendering here. So it is rendering a black plane here. Okay, fine, fine. Now after 1 hour, after a long time, our initialization function is completed, and after this, it will be really smooth and really easy to understand the code. So now we have set up our initialization function. Let's set up our animate function to animate the wheel and animate the grid. So now let's create the animate function. Const animate equals to, you are using arrow function and you are using controls dot update so that our animation will be updated in each frame. So we are using this time function. Time will be minus performance dot now divided by 1000, and for the wheels, for each wheel, I'll be rotate that wheel on x-axis. Rotation, sorry, wheel dot rotation, rotation dot x equals to time into math dot pi into 2. And for the grid, we're using grid dot position dot z equals to minus time percent 1. And if renderer is, and after that what we will use is we will use the renderer dot render. For we are using render, okay. And for the renderer, if renderer is present, renderer is present, renderer, if renderer is present, renderer dot render. Now we will render the scene and the camera onto the canvas. Scene and camera. Now let's see what it does. And for this animate function to call, we have to call it in here, so that this animate function will call on a loop. If I reload the page, as you can see that the grid is already animating, but the 3D model is not. Okay, the 3D model is also presenting. As you can see that our 3D model is right here. It is right here. So, and it looks so fucking cool. It looks so fucking cool. As you can see that we have successfully rendered our 3D model, and the wheel is also animating and the grid is also animating, and it looks nice. So now what I will do is I will remove this background and the height of screen properties, and let me see what it looks like. And it is looking good. And I will remove this text also. And if I reload the page, nice, it is looking nice. So our 3D model has been successfully rendered with our custom animation. Now we have successfully rendered our 3D models and the grid animation as well as this wheel animation. But there is one problem here. There is overflow. It is creating overflow here. So let me fix this overflow first and we will proceed with the code. So to remove this overflow, it is really simple. In this main container ref, just write overflow in x hidden. If you do this, and as you can see that the overflow is removed. So now we have this 3D model rendering perfectly. But in use effect, if you are using like React and Next.js, you are initializing this many thing, and when the component unmounts, unlike the main vanilla JavaScript, you have to write some cleanup function so that your code runs smoothly and there is no memory leaks on your code. So that when you leave this component and go to another page, so that this animation in background should not run, and it will prevent from memory leaks, which will help in the performance of your React application. So now we'll do is I will write some cleanup function for this. So in use effect, you have to write cleanup function like this. In the return statement, you have to create an arrow function, and inside this, for the controls, I have to remove the controls first. So I will remove the controls by calling the function controls.dispose. So this will remove our controls, and if renderer is still present after the component is unmount, I also want to dispose the renderer. And after that, if renderer is still present and renderer has still the DOM element present, I will also have to remove the DOM element from the renderer. So from the main container, sorry. So from the main container, I have to remove its child renderer dot DOM element. And after that, the last step will be to clear our scene. So to clear our scene, we have to remove scene dot clear, just like this. And if I save this and reload the page, as you can see, our code is working very much perfectly, and it is running a little bit of smooth. So now we have successfully rendered our 3D model. Now our next step is to customize this material, this glass and their color details that we have specified in our code. So firstly, we have to build the color picker UI here. So I will uh, copy and paste this code. I have already written that code. So what I will do is I will just copy and paste this whole code here. So that this is 3GS video. So I will not waste your time writing some boring CSS. I will create a div. Sorry, I will create a div like this, and I will make it relative. Relative, and I will just copy and paste this code right here. So it is using some value. I will just comment this code and I will write this function later. I will comment this code, and if I save this, and if I reload the page, as you can see that our customized color card has been created with the details like body details and glass. And if I click this, you can see that uh, we can see a color picker here, but the color is not changing, I know, but we have not written its logic. So to return, write the color and details class logic to change and reflect on the car in real time. We have to create a use state and update its value. So to do that, let me go up right here, and I will create a variable for the body color detail and glass color so that it will dynamically render on the car. So let me create the variable first. First I'll create the body color and set body color use state. It will be of type of string, and I will have to pass the initial value first. So the initial value will be what is the body color variable, body material. This is the initial value. I'll just copy this right here, and for also do the same for the details and glass color, and just like this. Okay, nice. So I have created this body color detail and glass color. So after that, I have to use this color on my code. So to dynamically change that color, I'll have to use it right here. I have hard coded this value here, so that it does not change. So now I have to make it dynamic, so I'll have to remove this color value and specify its color. But you cannot give it like this. If you are using in Three.js, you cannot give like this body color and it will just change right in the real time. You have to specify it like this: new 3 dot color, and what is the color? Body color. Just you have to specify just like this, and same for the details and same for the glass material. New 3 dot, sorry, details color, and for the glass color, new 3, sorry, 3 dot uh, color, glass color, just like this. So after that, uh, it will still not change because we have not specified that value in our input field. So the default value will be this, and on change you can uncomment this code. And if I save this and if I just reload the page, and as you can see that the default value is applied on the color picker. Now if I change, it will still not change. Why it is not change? It will still not change because as you can see that it is inside this initialization function, and I am updating this variable based on the color picker. But as you can see that this function is too much of a heavy to re-render. It will have to re-render all of the things and to re-initialize all of the things like scene, control, camera, grid, all of the things, so that it will be too much of a heavy to re-render this whole fucking code. So in order to tackle this problem, we have to use ref, so that the reinitialization should be uh, very smooth without re-rendering the whole use effect code, which is too much of a habit to handle on the browser. So to solve that problem, we will have to use useref for this. So what I will do is I will create a useref for material, details, and the class material. So I will create a body material ref equals to useref, and it will be of 3 dot physical material, mesh physical material, and it can be of null also, because at initial the value will be null, and just like this. And for detail and glass I will do the same thing. And after that, what I will do is, after this use effect after this use effect I have to update that value in our ref. So I will create another use effect so that this use effect will not run after I change the color, because if this use effect will run and if I pass the dependency areas body detail and glass color here, this whole code will run until I select the color, and which will cause too much of a performance issue and the whole website may crash. So I will create a separate use effect here, and I will assign the value in the ref. Sorry, I mean like this. So if body material ref dot current is present, what you can do is body material ref dot current dot color dot set. You have to specify the body color here, just like this. So I am storing this body color variable inside this ref so that it does not trigger re-render on the code. So if I'll do the same thing for the detail and glass material. If details material ref dot current details material ref dot current dot color dot set details color, and same for the glass material ref dot current and details, and I think glass material ref dot current dot color set glass color, And this use effect should run if I change body color, details color, and the glass color. So now if I save this and if I run this fucking code, and let me see if it works or not. I hope this will work. Otherwise, I have no other answers. So if I click here and if I change this, oh no, it is not changing. Why the fuck it is happening? I don't know what is happening, but it should change. It should have changed. I think there is no any fucking error here. So what may be the problem? If I again reload this page, if I again reload this, oh sorry. So there is one problem. I mean I have not added the full code. So if we are using body material ref, details material ref, and this ref, but we are not assigning it on our initialization code. So what do I mean by that? So right down here I am using body material from this color, but I am assigning this value on our ref, but we are not using this ref anywhere in this code. So what I will have to do is inside this body material I'll have to use it body material ref. So I will use body material ref dot current equals to body material. So I'll have to assign this body material into our body material ref. Same thing for details and glass. So details material ref dot current equals to details material. For the glass material is also the same thing. So glass material ref dot current equals to glass material. Just like this. If I save this and if I now reload the page, now if I change this color, I hope now this time it will change. So if I save this here, as you can see that it is changing in real time. As you can see that the color is changing in so much smoothly in a real fucking time. As you can see that, and this looks so fucking cool. This looks so awesome. And for the details, let me see if it changed or not. So as you can see that here on the car wheel rim, as you can see that the color is changing. So if I do pink color, it is also changing green, blue. As you can see, it is working perfectly. And for the glass, let me change the glass value also. As you can see that the glass is also changing. And if I do this, and it looks so cool, it looks so fucking cool. As you can see that this car looks so amazing. So this is how you can build this car customization model in Three.js using Three.js, NEXT.Js, and in TypeScript or Tailwind CSS. I am using that tech stack here. So this project is so fucking cool that you can use it on other website also. You can use it on agency website, like, or you can redesign uh, your whole any car website that you want. Or if you want to build any car website to the client, and you can ask the 3D model of that car for the client, and you can make customization to this and present it on the form of website, which will look so much unique and so much fucking cool. So this is how you can build this thing. So I hope you like the video, and if you have any confusion related to this code, you can ask me in the comment section, and the comment section is all yours. So and I will see you in my next video. Thank you.